This is the video going over the Chapter 1 multiple choice problems. All right, so question 1 was one where they had an outlier as their maximum and then realized that it was way too big. It was not 10 times big, that it was 10 times bigger than what they meant. So they corrected it, and now it's not such a big outlier. And they're wondering what remained the same. Well, the mean and the range are not resistant to outliers. Download it so I can annotate. Okay, the mean and the range are not resistant to outliers, so we know it is not those. The median we know is resistant to outliers, so that is our answer. And we haven't talked about mode and variance, so that's a hint that it wouldn't be the answer. Mode is the most common data point, and variance is that standard deviation squared that came up when we calculated standard deviation. But you don't need that either. So it is median. Okay. Number 2, the big thing to notice here is that these are relative frequencies and that we don't know the number of kids in each grade. There might be a really big number of ninth graders. There might be a really small number of ninth graders. We don't know. So that is the key to figuring out which one works or not. So these ones in A, B, and C, they keep talking about, or A and B, they keep talking about the number of students, and that we don't know because we don't know the total number of students. All we know is relative frequency here. Okay, so we can't answer A and B. We don't know the total number. For C, you cannot combine relative frequencies. Both grade 6 and grade 7 were 30%. But we don't know out of how much. We don't know the total number of students. So you can't just combine them and make it 60%. That won't work. So then it's down to grade 12 of the least relative frequency. Because we're talking about relative frequency, we can do that. Okay. Problem 3. I always find it really helpful when I see a two-way table to automatically put in my totals. It just helps to have all the numbers there and you can pull them out as you need. And this was just a lot of work. I had to go through each answer and actually figure out how many kids it was that they were talking about, and then divide them on a calculator to get a decimal that I could actually compare. So this one was correct. This one was not correct. This one, that's not correct. So I just had to go through and actually pull out the numbers and figure it out and see which one was correct. And it was A. For number 4, we wanted to know which one had the highest standard deviation. So think about that. What that means is the highest average of the points away from the center. We want points as far away from the center as possible to have the highest average. So on all of these, they have about the same mean there, right there in the center. And so B is your answer because all these points are as far as possible away from the center and therefore have a high deviation, a high difference if you were to subtract them. And when you average all those out, you get a higher average. So B would be the highest standard deviation. Okay, so for question 5, again, they gave us relative frequency, but this time they did tell us the total number of students. We know there's 100 students at Liberty High School and 60 at Central High School. So we were able to calculate actual numbers from that. You know, like 4-year of Liberty High School would be 20% of 100 or 20. So we did have the ability to actually calculate numbers here. So again, it's just a lot of work. I had to go through each problem and figure out the actual number based on the chart. You're just pulling information out of the chart and see which one actually gave us an accurate statement. And it was E. Okay, for number 6, let's see. This one, honestly, I had to read it multiple times to even understand what they were saying. There were so many words in here, and this will happen. Statistics is so many words, and the reading and the writing is the hardest part of it. Okay, so what they were saying is that these 3 values were outliers for the younger group. So they did that for you. So now they wanted us to use our outlier rule and apply that to our older group and see if any of those 3 values were outliers for the older group. So I just had to apply my rules. So I wanted to see if I was less than quartile 1 minus 1.5 IQR. or greater than quartile 3 plus 1.5 IQR. So I just did those calculations. So to be an outlier in the older group, you needed to be less than 61 or greater than 85. Well, the only ones of our three numbers that fit that bill was 60. So 60 was our only outlier, which then you go down here, that makes B your answer. Okay, for 7, the key here was categorical data. So think about, like, if you were to ask these questions, what kind of answers would you get? How many blue cars would be a number of cars. Gas mileage would be a number, whatever, 20 miles per gallon. Weights and pounds, that'd be a number of cars. Here's where we hit a category. Colors of the cars in the lot. So the answer is E. Now for 8, I screwed up by putting this on the review because we have not talked about percentiles yet. That will come right at the beginning of chapter 2. We'll talk about it now because you probably put some time into it, and it's a good little preview of chapter 2, but something like this will not be on the test for chapter 1. Okay, so what percentile is, it's the percent of the data below a certain data value. You've seen these numbers in real life if you get your SAT score back and you see that you got a 70th percentile. That means 70% of people who took the SAT that year did worse than you, and 30% did better than you. Okay, so we wanted to know at 85, so this dot was what we were interested in. I had just counted up the dots. There were 28 dots total, and 85 was the 20th data point in. So that means 19 data points were below our point in question. There were 19 below our purple data point. So 19 out of 28, that is 68% of the data was below that spot. And so the closest answer to that was 70. So that's our answer. Number 9. So this one I had to estimate the numbers of how high the bars went. And I just, did my best, just estimate it as close as you can. Put a straight edge like a ruler or notebook up if that helps you. So let's see, which one could be the median? There were 175 data points total. So I thought, okay, what if there were 174? Well, 174 would give me 87 on the bottom half and 87 in the top half. So that means the 88th data value will be the middle for 175. It's an odd number, so there's a specific data point that would be right in the middle. It'd be the 88th one. So then I just counted through the bars. We have 80 of our data points here. So wherever our 88th one would hit, it would be somewhere in here in this bar. So it's somewhere in between 5 and 10, probably closer to 5, but we don't actually know that. So 7.25 is our answer that's in between 5 and 10. Okay, number 10. This one, let's see. So we're looking for interquartile range. So we need to figure out quartile 1 and quartile 3. There are 100 data points total, and quartile 1 hits 25% of the way in. So 25th data point would be quartile 1, and 75% in, you're going to get quartile 3, so the 75th data point. So I just counted through. I thought, okay, here's our lowest 8. And then 8 plus 13 would be 21. So I still haven't hit 25. But then I would hit 25 right here in 11. And then I could count up to 75. Instead, I counted down from the top another 25. So 25 in from the top. So here's 1, add 2. We've got 3 data points now. Add another 5. We've got 8. Add another 3. We've got 11. Add another 5. We've got 16. Add another 8. We've got 24. So 25 in from the top end is going to land somewhere in here. Okay, so this one, the bottom one, is between 9 and 11. The top one is in between 15 and 17. So I just guesstimated, okay, let's go with 10 and 16, kind of in the middle. So that would give us an IQR of 6. So I went through and I found the one that was closest to that, 5. Number 11. So we have some information. I looked at the graph, noticed that it was skewed right, had some potential outliers at the top. They reminded us of our outlier rule again. And we are figuring out which one describes this distribution the best. So the first thing they talk about is the median versus the mean. Well, it's skewed right. And remember that the mean is not resistant to outliers. So if there are outliers up here, they are dragging the mean to the right. The median is resistant. It's not getting drug anywhere, but the mean is getting drug higher than the median. So mean is higher than the median. That means the median is less than the mean. So I can cross these guys out. So then I now have to decide, is there one outlier or two outliers to narrow down between my two answers? So I just did my rule. The IQR is 3 because it's how far apart these guys are. I did going down from quartile 1, I would have to be at negative 2.5 to be a lower outlier, and there's none. It stops at 0, so there are no low outliers. But the high outlier, I would have to be bigger than 9.5. Well, 9.5 is, like right in here-ish, so there's 10 and 12 are 2 outliers. So it has 2 outliers. Okay, that's the end of the packet.